Hey there, Dango Stu here. Today's video is on how to not get a job finished. So as I said last week, I was going to do the seals in the Evinrude, but I need some threaded rod to use with my puller to get the bearing carrier out, and I don't have any threaded rod of the correct pitch. And being an American outboard, I need to get some imperial thread, and I can't get that from anywhere other than an engineering shop that's not open on weekends. So next week. Then, to compensate, Paul had been painting his Tatsu outboard, and I posted a picture of it in progress on Instagram. And somebody said, "Oh, are you doing a video in this?" And I thought, well, no, I hadn't, but why not film the last part of this process? But it turned out that the Tatsu paint that turned up is actually green. I have no idea why. I don't think I've ever seen a green Tatsu motor in my life, so we couldn't finish this one either. Week after next. Then I thought, I know, we can go through replacing the bearings on these forward and reverse gears from when I changed the dog clutch or some old video, I can't remember. But then I realised that the spigot bearing puller I have doesn't open far enough to get the bearing race for the forward gear out, so that would have been a bit of a lame half video too. Then I thought, I know, I've got a kit for a sender and a fuel gauge, so I thought I could put a fuel gauge on the green machine, but the sender unit's actually taller than my fuel tank is deep, so I can't do that either. But I will. I'll make a fuel tank. I'm going to make a tank, put the fuel gauge in it, but not today. Another photo I posted on Instagram was of this water pump impeller. As you can see, it's very chewed and wasn't pumping any water at all. Now this outboard came in essentially just for a service to be swapped from one hull to another, so I don't really know the history of it, but when it started up it was running quite badly. I cleaned the carburetor on it and put some new plugs in, but it sort of runs poorly and it backfires a bit. So I'm starting to wonder whether maybe it's overheated badly at some stage and there isn't a bit of damage to it, maybe a head gasket problem. So I thought we could just do a bit of diagnosis on that one in lieu of every other idea not panning out today. What I will do is start by putting the new impeller kit into this. It's not a video about doing a water pump, but I'll just go through it quickly, some of the points about it being quite damaged. We'll see what came in this kit too, because obviously there's a lot of molten rubber inside the cup and all that kind of stuff as well inside the housing. So we'll fix that up, and then I'll fire this up and I'll show you what it's running like. Before I do this water pump kit, I'm just going to drain the oil in this, because now I'm down to having the pump plate off. I can maybe see if I need to do the drive shaft seal before putting the pump in. So we'll just see what condition that oil's in. So this oil doesn't look too bad. This is the oil from this Yamaha. The yellow oil is the emulsified oil from the Evinrude 150 that I drained just before. So we'll push on with this pump. Under here is just little fragments of rubber from the impeller. So I'll clean all this out and then we'll start putting the new pump back together. So this is the kit I'm going to be using. This is the part number for it. So it's got a new pump housing, which is good. Saves me cleaning up the old one. The impeller, of course. Some new bolts for the housing. New woodruff key. New O-ring. And a new base plate. So the base plate has got a lot of rubber melted to it, and the internals of the pump housing has a lot of rubber too, so I'm glad we're just going to be replacing both of those. To get this housing out, I'm just going to rest the edges here on a vise, and then I'm just going to tap it from the top and just sort of punch it out. With this vise, I'm just going to open it far enough that the pump casing here rests on the edge, but the internal pump housing here can drop down. Then I'll just get a little punch and a hammer. Before I start, I'll just use this pick to pull the old O-ring out. So we'll get rid of that. I'm going to sort of use my hand to try and hold this to stop it bouncing while I tap it. Starting to come out easily enough. All right, so old housing out, old O-ring out. So down in here, what I thought was a bit of impeller blade I could pull out is actually this pump housing having melted. So it looks like the curse is continuing. I've just figured out why everything's going wrong today. It's because I don't have any beer left. I've always said it, don't try and fix an outboard without a beer. This is what happens. Given everything else has gone a bit pear-shaped, one thing I did want to talk about though was making a little remote engine starter. They're great for checking things like spark, where you need to be at the back of the boat. We touched a bit on that in the what to do when your boat breaks down on the water video a couple of weeks ago, but I don't think I explained it very well. So what I will do actually is just quickly jump up to the chalkboard. I'll draw the circuit for the starter solenoid and then talk a little bit about this switch. It's pretty simple, but I probably should just explain it properly. Oh, you may have also noticed that I went and got a steel rim from a scrapyard. They also had these sash weights, just lead weights at the scrapyard. A bit of gal pipe, so just welded that in the bottom, and then just a little bit of plate on top, so I can have my, outboard leg holder here and a little platform for the grinder. It's kind of not ideal in that you don't want to be grinding onto outboard legs, but quite often I'm either doing one or the other, and it means I can put this wherever I want, which is great. It's no longer in the vise because that was a bit of a hassle. The other good thing is it means if I'm doing a lot of grinding, I can actually move this pedestal near the door, let all the grinding dust just end up there where I can sweep it up more easily instead of ending up all over the workbench. So I'm so far pretty happy, and surprisingly, even with that really heavy Evinrude gearbox in it, it's quite stable, more than I thought it was going to be. So that worked out all right. All the starter solenoids have 4 connections on them. So this is an aftermarket Sierra one. You'll see there it replaces a Mercury and Yamaha unit. So this is what they look like generally, very similar to this, where there's 2 large terminals and 2 smaller ones. So I'll draw that on the board and we'll show what it does. So if you imagine a unit here, it's got 2 small connectors and then we'll call it 2 large off this side. Then the way it works is your battery, it's a positive and negative. Negative goes to some earth. Then your positive will come up to one side of the solenoid. Up here then you'll have your starter motor, and then the positive comes up to one side of the starter motor, then the other side comes down and goes to ground. So these 2 connectors are the 2 large terminals that carry quite a high current. So the current it needs to crank the motor over. Hundreds of amps essentially. So up here you'll have your key switch, either your forward controls or could just be a push button start. But one of these wires, this red one in particular, you'll see this has got just a loop for the black and a bullet connector for the red. So your red's attaching to your loom if it's forward controls, or up to the starter push button on the cowling if it's a tiller steer. And then the other one here just comes to ground as well. So that's what the ring connector is. Your forward controls also pick up a positive power. Often it does come from the positive terminal on the solenoid. That's a very common place for outboards to pick up power from because it's basically a direct connection from the battery. So your forward control picks up power from there and sends it to here. Now, when you turn the key, all this is a switch. When that switch closes, positive power can run up to your switch, come to your solenoid. It then activates a coil, goes to ground. When it activates a coil, it closes this switch, and that allows power to run through your starter motor. Now this circuit here is often fused, so if this fuse blows, when you turn the key, no current flows through this coil, which means this solenoid won't click, you won't hear it activate, and no power is allowed to run to your starter motor. So in that video, when I was sort of bypassing this whole circuit, all I was doing was using that remote starter to take some power from here and apply it to here. Then a small amount of current flows through the wires of that starter switch to ground. It activates the circuit and then allows the high current to run to the starter motor. So this switch is one I had lying around. It sort of suited me because it's actually got a bit of a handle to it. You know, it's large enough. It was actually a limit switch for a cart. So as the cart went by, there was a roller on the end here. It would come over the roller and cut the power to an inclinator. All I did then was go and get a little sort of radio knob style thing from J-Car, took the roller off, put that on the shaft, then had 2 wires, don't have to carry a lot of current, so don't have to be huge, and put on a couple of alligator clips. And that's really all it is. 2 alligator clips and a momentary switch. So really straightforward. Then what I do is I hook the red side to a source of power. That could be straight to the battery positive, could be the terminal on the solenoid where the battery positive come to. I just need 12 volts. Then all I need to do is connect the other side, the black side, to the positive on this solenoid. So there's 2 small wires. One has to go to a ground, then the other is where I hook the black one. In this case, if my battery positive came straight to here, the other one went off to the starter motor, I would hook my red to the one where the battery came into, like that. I would hook my black to essentially the positive coming in. I could, if I had enough room, I could simply go on the nut here as well. And then when I hit the button, I'm just supplying 12 volts to there to activate the solenoid. So one common mistake I see is where people connect them across the 2 large terminals like this. If you do that and you hit the button, all the current for trying to start the motor is passing through your switch, and you don't want that. This will get really hot, the wires will melt, it'll get nasty really fast. The one advantage to that is that if the solenoid itself is dead, you can still start the motor. If the solenoid's not functioning, supplying power isn't going to make it work, but doing this will. But if you're going to do that, you need a switch that can handle hundreds of amps, you need alligator clips that can handle hundreds of amps, you need wire as thick as your battery leads. The whole thing needs to be much, much, much chunkier than it is. So that's not the idea with this particular unit. So there are 2 main benefits to this. One is that you can start the boat should your key mechanism have failed, that kind of thing. And the other is when you're trying to diagnose a problem. To be able to stand there with the cowling off, hit the button, look at your spark tester, listen for a strange noise coming from the starter motor, all that kind of thing, means you can diagnose jobs on your own without needing someone at the front of the boat, someone at the back. So it's a really good reason to put one of these together. To make one of these, you buy all the parts for sort of under $20 at your average sort of J-Car electronics store sort of thing. Nothing special about the switch, nothing special about the clamps, anything, you know, just use whatever you can find lying around. If you can't find a larger switch like this, might be good to mount the switch onto some sort of handle so you can use it. That might be a little project box or something, but just something to make it a little bit more comfortable to use so you also don't have exposed connections and wires and things like that. All right, well, take care. As you've seen, there's a few things in the pipeline, so they'll all get finished over the coming weeks, and I'll get those online definitely, and then we'll push onto some new stuff as well. All right, see ya.